Assalamualaikum. Again, we continue with the second part 2 of 3 on the Cathodic protection. So today we'll be going through the typical drawing, installation details of a cathodic protection, the sacrificial, and the comparison between sacrificial anode versus the impressed current cathodic protection. So this is a typical cathodic protection layout plan. So this is for a plant with underground fire water. You can see here fire water piping, cooling water piping. So there's a lot of underground piping going around throughout the plant. So normally the fire water they are using carbon steel piping. So with coating lah, epoxy coating normally. So this plant uses A, which is a deep well type ground bed. And we have here the anode junction box. So this deep well can go as deep as 30-40 meters or more. So how deep or how shallow it should be, it will depend on the soil resistivity and the soil resistivity at which depth is the best cathodic protection anode bed to be installed at which depth. So you have your anode bed here connected to here, which is here you have your transformer rectifier, and also your anode junction box, and also your negative junction box, which is your cathodic junction box lah. So your negative from here will be connected to one or more points on your fire water pipeline. So you have your anode, you have your pipeline to be protected, which is connected to the negative JB, your anode connected to the anode JB, and it will be connected to your anode is connected to the positive for your rectifier output, and negative or cathode is connected to your negative of your rectifier output. So there's two systems here. One, this is the first system, TR rectifier number 2, transformer rectifier unit, and this is the transformer rectifier unit number 1. So 50 volts and 10 amps, this is the output of your DC rectifier, the maximum it can go. It's not always at 50 volts or 10 amps, but it will depend on your, when you do the, once you switch on and you do the first commissioning, which is the closed interval potential survey, you will know lah what voltage and what current that it's supposed to be maintained continuously all the time for the next 15 to 20 years. Okay, so this is a typical cathodic protection layout. So this is your anode bed, typical anode bed. This is using a what? Guessing this is MMO. Yes, this is MMO string, multi-metal oxide string anode. So normally when you do the drilling for your anode bed up to 30-40 meters, so you will also use your your drilling bit as part of your soil survey lah during. So when you drill up to 5 meters, then you measure the soil resistivity at 5 meters, then 8 meters, 10 meters, then up to as deep as you want lah. So then you'll know which depth is the best soil resistivity, and to size also your cathodic protection lah. So you have your MMO, which is just a string of MMO, multi-metal oxide, and there is also a perforated vent pipe hose. This one, when there's some reaction, there'll be some gases released within this anode, so that's where that vent pipe will allow that gas to be released. And you also secure it with a 8-inch steel casing welded continuously, and carbonaceous backfill, which is the ground enhancement material. So this material will assist the interaction, means it makes less resistance lah between the MMO and the earth. Because when there's any corrosion happening on the pipeline. So this corrosion will interact through the earth the MMO will interact with the corrosion through earth to corrode. The MMO will corrode so that the cathode is protected. Okay, this is a typical typical anode bed. Alright, so this is another type of anode bed. Also, this is positive feed cable, also MMO type. So you have a breather here to release any gases. Then from your anode, it's being tied here to the steel boat PVC roller. So basically it's being hang here. So normally you will hang this anode, then you will start to backfill this 8-inch white with the ground enhancement material all the way to the top, almost lah to the top. Okay, then the positive is the anode is connected to the positive anode junction box, which goes directly to your positive side of the rectifier. So we have here your rectifier, which is just a transformer rectifier unit. You have your transformer, basically to step down from your 415 or 240 volts to the voltage that you require to be rectified. Normally 50 volts or 100 volts or 30 volts. So it depends on the size and of the required protection. Okay, let's see here. This is a schematic. So you have your input 3-phase 415. So you have your transformer to step down. Then you have your, it's a double circuit here, circuit 1 and circuit 2. So you have your transformer, also acts as an isolating transformer. Then you have your handle here, which you can regulate the output from 0 to 50 volts. So it's not maintained continuously at 50 volts. You will need to regulate this when you do the commissioning. Then after commission, it will maintain at that whatever voltage that you have selected. Then it goes through a rectifier. Rectifier as well, then goes to your ammeter and your voltmeter, and this is for to detect your DC fault. Okay, so this will go to your deep well ground bed system, then the wire anode system. If it goes to a shallow bed system. So the anode cathode JB is just a normal JB. You have a JB junction box containing in it a bus bar, which will connect one TRU circuit 1, TRU circuit 2, which comes from your transformer rectifier unit, and one cable or more may go to 1 or 2 pipeline to be protected. So this is another anode JB. So you have your wire anodes. This one is to TRU circuit 1, TRU circuit 2. So some of the anodes may be going to the deep well. This one may be going to another deep well if there's 2 but normally okay. CP schematics, the simplified schematics. So you have here your anode connected to your cathodic JB or your anode JB, then connected to your positive of your rectifier. Where else the negative of the rectifier, DC, negative DC is connected to your negative JB or your cathodic JB and this one will be connected to your pipeline. So normally the connection between here at the pipeline will be using thermal well. We rarely use C-clamp or bolt nut connection between the pipeline to the JB, because we want it to be secure and to be left without any maintenance for the next 15 to 20 years. So if there's another JB there's another ICCP connection in between, so normally you connect between these 2 pipelines through a bonding junction box bonding resistor junction box. So you control the resistor so that the ICCP 1 and ICCP 2 will not interact with each other meaning ICCP 1 will not protect this 5 water pipeline, or the ICCP 2 will not protect the ICCP 1 pipeline or under protect it Okay, so this is the CP schematics. So this, you also have test station details. This is where you do your monthly check. This is normally located for a pipeline I would say every kilometer or every 1.5 to 1.5 kilometer, you have your test station details. So not test station details. You will install with test station, where one part of the pipe of the test station is connected directly to the pipeline through termite well connection. Whereas the second, there's also another part which is left open. So when you go through your monthly measurement or quarterly measurement, you will bring your multimeter. One part of the multimeter will be measuring DC. So one part will be connected to a copper sulfate reference, and you poke that copper sulfate into the ground, and that copper sulfate reference is connected to the positive of your multimeter, and your negative multimeter, negative DC voltmeter is connected to your test point. So it will measure during on off of the cathodic protection. So you will have, if it's in the on, there will be some readings, should not be more than 3000 millivolts. When it's in the off condition, it should maintain around 850 to 1150, and after it's being polarized, it should not go below than 750 or so. So that one we will go later in detail in terms of the maintenance for the test station and the cathodic protection. So this is the CP bonding at underground valve. So this bond cable means you are directly connecting two different fire water line. So this is direct bonding. So, and this is also CP bonding at the sewer pit pipe, because maybe this is going to a bunk containing whatever sewer water, whereas this pipeline and this pipeline is not connected, so it needs to be connected through direct bonding so same goes here. So one ICCP can be connected to more than one pipeline so you have to size it accordingly. So this is how the cable is, the insulated cable will be connected to your pipeline. So they will use a termite well connection or thermo well connection, thermo well concept. So the coating will be removed. I think there's explanation on the second page. Next few pages, we'll go into the details later. This is another component of your cathodic protection, which is your electrical isolation kits. So here you have your insulating flange. So between these two pipelines, there will be no electrical connection because you are using, one is the insulating gasket. One is the insulating gasket. Also you have your insulating sleeves. And your insulating washer, everything, but your bolt and nut is still metal but there will be no electrical connectivity between these two pipelines because of this isolation flange insulating flange. So it's basically due to your insulating gasket plus your insulating sleeve and washer of your for the bolt connection. Another type is the monolithic insulating joint, or in this case ISO joint. This ISO joint is the brand or model being sold by this company EPS online. So it's insulating coating outside. So between these two metals there will be an isolating film material which is non-electrical, non-conducting so it will make sure. So normally this side will be coming from the underground pipeline, so this side will be going to the above ground pipeline, so that the cathodic protection will only end here. It will not go all the way up. So the above ground pipeline will not be cathodically protected. So same goes for here it's the same concept as the MIJ. Monolithic insulating joint, or we call it MIJ. So this is how we connect the pipeline and coating reinstatement. So you will have to remove your coating, then you strip your insulation from the wire, then you put your thermo-well kit on top of the knee. So then once you have performed the thermo-well process, so remove the slag with the hammer, so make it smoother, Then you will coat with a primer, which is normally epoxy coating. Then you will wrap it around, wrap all around until you maintain the insulation, so that there will be no interaction with the atmospheric or the soil condition. Okay, so this is what they do lah for connection from the negative junction box to the pipeline, for the connection from the test point to the pipeline. So this is how the thermal well connection and how it's coated back to maintain the no interaction between the pipeline and the atmosphere or the environment. So this is a typical installation for the shallow ground bag. This is the junction box for the anode junction box being connected to the shallow ground bag lah. So the depth is not too deep, maybe 3 meters, 4 meters, so it depends, because normally it's being used to protect the under surface of the pipeline lah. Oh, sorry, the bottom surface of the tank. If it's directly sitting on the soil. Okay. So comparison galvanic versus impressed current cathodic protection. The installation area for the galvanic anode, normally the coverage is very small. So if you want to install for a 10 km pipeline, you need to install it every few hundred meters or every 1 kilometer, something like that lah. So for impressed current, large current are needed, so you need that DC rectifier up to 100 amps, but the coverage it can go 1 CP can cover up to 10-20 kilometers pipeline, no problem. Okay. Alright, soil resistance, galvanic anode is normally used for those in low soil resistivity. Where else for impressed current, you can use it anywhere because you control the output of the DC rectifier. Can be 30 volts, 50 volts, you can make it as cathodic as you want. Application, this is for a single unit steel structure protection. For example, in the jetty, under the boat or small boats. For entire steel structure, then you need ICCP lah. Operating voltage is low, 0.76, 2.37 from magnesium. This is the natural voltage potential lah between two dissimilar metal. Where else for operating voltage is high voltage with respect to the cathodic protection. So 24, 36 volts. There are some up to 100 volts DC. So leak CP protection suitability. This is suitable. What does it mean here by leak CP protection? Means if there's any, there might be some areas that may not be protected by the CP. So you can install this galvanic anodes specifically for the area. So it will cover to top up that CP leak there lah. But for impressed current, not suitable due to costly lah. For example, if you already design an ICCP up to 10 kilometers, but there is one last kilometer portion that after you've adjusted the voltage and everything, it still cannot protect that one. So you don't want to install another ICCP. So because of the cost, so normally you'll just install additional sacrificial anodes. Okay. Stray current suitability, galvanic corrosion is not affected by any stray currents. Where else impressed current, not practical and will be dealt separately lah. So stray currents can come from the earth, from the natural stray currents like lightning, or from DC sources like if there is a nearby DC track, for example like your your commuter, so you pakai, or your rapid line, it uses a DC, so that DC can affect lah. Or your ICCP is near a steel mill, so there's a lot of there can be a lot of stray currents when they do the melting lah. Okay, so that are the sources. For galvanic it's not affected, but ICCP is affected, but no issue because there is ways to block that stray current from reaching your pipeline or your ICCP system. For effectiveness, galvanic anode is normally used only for shallow buried steel structure. For impressed current, both shallow and deep buried steel structure. Cost, of course, galvanic is cheaper. Impressed current, costly lah and complex design. Installation, impressed current ICCP is much difficult and more complicated. output current is fixed because you cannot adjust anything. You know, if it's, for example, you are using magnesium and ferrum, so magnesium and ferrum will be 2.76 volts between these two. So it will be 2.76 volt forever. So you cannot change that. But for the ICCP, you can control the DC output or the transformer rectifier. For lifespan, not so lasting, but at least 15 years lah for ICCP. But this one is very subjective. If you design for 20 years, you can install as many as the weight required to last for the next 20 years. So, but there will be a lot lah. Okay. Maintenance, galvanic anode or sacrificial anode, you just leave it as it is. So schedule for ICCP, you will require scheduled maintenance because you fear that the coating may be damaged, so you might have some CP current leakage at that point lah. So you'll have some maintenance that we will go through the maintenance schedule in the next part 3 of 3. Okay, that is all folks for part 2 of 3 cathodic protection. Thank you for watching. For any latest updates, please browse through my YouTube channel, Crux of EE, or you can also subscribe, like my FB page, facebook.com/Crux of EE, and also I'm on Instagram and website. If you have any questions, you can email to this address or can just leave your comments below. Thank you.